When you look at a car, you generally consider its looks, power, and torque figures. It's probably safe to assume that most of us spend very little time thinking about a car's braking ability, and undoubtedly many of us barely considered what a car will do to help in an emergency stop. You may have seen ABS, EBD, or BA mentioned somewhere in a brochure or a car advertisement. These are all the cutting-edge car braking technology. ABS, known as anti-lock braking system. EBD is electronic brake force distribution system. And BA, known as braking assistance. Almost all of us are aware of such terms, but only a handful knows what exactly they mean, and how exactly they strengthen the safety department of a vehicle. Their functionality is completely different from that of the regular brakes, and these are considered much safer for the occupants. These features are present in a number of vehicles from the hatchback, sedan, compact SUV, and multi-purpose vehicle segments of the domestic market. So let's understand these topics differently, starting with ABS. As the name implies, ABS prevents the wheels of the car from locking up when the car applies the brakes suddenly in certain situations. This type of brake allows the driver to have complete control of the car's steering when maximum force is applied to the brake pedal. Generally, when the driver suddenly applies brakes to a moving car, there is a high probability that the wheels will get stuck due to the sudden brake force and slide on the road. This happens because the momentum of the velocity of the car is carried by it, and the wheels are unable to convert it into rotational motion due to the brakes. ABS, or anti-lock braking system, is a piece of safety equipment that prevents the wheels of a vehicle from locking up under emergency, panic, or harsh braking conditions. When braking on wet surfaces during rains, you tend to depress the brake pedal to its full limit and eventually end up locking the wheels. At this point, your car starts sliding straight without directional control. The situation becomes worse when all this happens uncontrollably. The loss of grip may result in the driver losing control over the steering of the vehicle. This may, in turn, lead to an accident. That's where an ABS comes to the rescue. Thanks to the latest safety regulations, nearly all 4- and 2-wheelers nowadays come with an ABS. The first primitive form of ABS was developed in the 1920s by French pioneer Gabriel Voisin, initially to aid braking on aircraft. Although, it wasn't until the 1970s that ABS was adapted and introduced to the commercial vehicle market on a large scale. The anti-lock braking system has 4 main components: speed sensors, valves, pumps, and controller. Speed sensors monitor how fast the wheels are rotating. Valves allow to block and release pressure on the brakes. Pumps are filled with hydraulic fluid and apply pressure to the brake drums on demand. The electronic control unit, ECU, is the brain of ABS and uses data from sensors to determine whether to pump the brakes or not. The speed sensors are located on the wheels that monitor the speed of each wheel. When sensors detect that your car's tires begin locking up, the electronic control unit reads the signal from each sensor and sends the signal to the valves of the respective wheel. Then, valves rapidly apply and release the brakes automatically to keep your tires from skidding and helps keep the driver in control of the vehicle. If speed sensors detect that the speed of any of the wheel is reducing drastically compared to others, the ECU sends the signal to the valves of the respective wheel to reduce the brake pressure, and the valves get closed. After this, the wheels start to accelerate again, and the signal is sent to the ECU one more time, which in turn sends the signal to open the valve and increase the brake pressure, and hence, brakes are applied. The cycle repeats itself until the application of brakes becomes normal. So essentially, ABS works in 3 stages. Brake pedal is pushed. Will sensors detect skidding or locking, ABS pumps the brakes. In a car equipped with ABS, what mostly happens is the system applies the brakes in small pulses to prevent sudden brake locking. That is why you can feel vibrations and juddering at the brake pedal when ABS is activated. When you feel or hear the ABS vibrating, continue to firmly press and hold the brake, then steer to safety. If your car doesn't have 4-wheel ABS or the ABS is not working, you'll need to slow your vehicle down as much as possible before turning the steering wheel. Take your foot off of the accelerator pedal, and if you're in a manual geared car, push the clutch down, push the brakes with as much pressure as you can, until you can feel your wheels lock, then release the brakes. Take your foot off the brakes, then reapply the brakes. This replicates the ABS braking method, ABS works most effectively when the tires are properly inflated and in good condition. Common causes of four-wheel ABS malfunctions include worn brake linings and air or dirt in the brake fluid. The primary task of ABS is to give the driver steering control during hard braking, not reduce stopping distance, as is the general misconception. That said, given the right type of road and conditions, that may prove to be the case. For example, on wet sealed roads, ABS usually shortens the distance required for a stop, but on gravel or dirt tracks, skidding may actually decrease stopping distance as the car's tires are able to dig into the surface. Besides the ABS, there is also the EBD, which stands for Electronic Brake Force Distribution. While ABS is the overall automotive braking technology, EBD is just a part of the overall system. However, both these elements are equally important in reinforcing the safety department of the vehicles. The EBD is responsible for distributing the braking power to all wheels of the car. Also helps in regulating and applying the braking force needed to each wheel according to the road condition, vehicle's load, and its speed. The EBD ensures how much braking force is needed by each wheel, and then applies the same in order to achieve the most suitable braking impact. For example, consider the most common scenario. In a front-engine car, front wheels carry a heavier load than others, and will require more brake force in order to bring the car to a stop, without it going out of control. The extra weight up front increases the grip of the front tires, while it reduces the grip of the rear tires. This makes the rear tires more likely to lock up during braking. When the rear wheels slip, the car can begin to fishtail or even go into a spin. Traditionally, braking systems included a proportioning valve to allocate the correct amount of brake force to the front and rear tires. However, with ABS, the proportioning valve no longer provides an ideal solution to the problem. EBD is based on the principle that not every wheel needs to put forth the same effort into bringing the car to a stop. That means an EBD system can not only detect how much weight is being supported by each wheel, but change the amount of braking power sent to each wheel on an instant-by-instant basis. When a car slows down, its weight shifts forward. In a front-engine car, this is where the EBD comes in. With EBD, an ECU determines the slip ratio of each of the tires individually. If the ECU notices that the rear wheels are in danger of slipping, it applies less force to them while maintaining, or, if necessary, increasing, the force applied to the front wheels. EBD is also useful when the car is braking while driving around a corner. While turning, the outer wheels of the car rotate more quickly than the inside wheels. If too much brake force is applied to the inner wheels, they can lock, causing the car to oversteer and go out of control. EBD can sense the slippage of the inner wheels and reduce the brake force on those wheels, without reducing the force on the outer wheels. A number of vehicles, such as Honda, Volkswagen, and Nissan cars have these features as standard. The same can be inquired through the Honda or Nissan car dealers while purchasing the particular models. An EBD system makes use of three components which make it tick: the speed sensors, brake force modulators, and electronic control unit, ECU. The speed sensor not only calculates the speed of the car, but it also calculates the speed of the engine. One of the scenarios can be that the speed of the wheel might not be the same as the speed of the car. Such a situation can lead to the wheels skidding. The speed sensors calculate the slip ratio and relay it to ECU. Electronic control unit. It is a small chip which collects the data from the speed sensors in each wheel and uses the data to calculate the slip ratio. Slip ratio is the difference between the speed of the car and the rotation of the tire. Once the slip ratio is determined, it makes use of the brake force modulators to keep the slip ratio within limits. Brake force modulators. It is the job of these modulators to pump brake fluid into the brake lines and activate the brake cylinders. The brake force applied on each wheel can be modulated. All these three components work in tandem and make the EBD work and save your day every time you brake hard. Brake Assist, BA, is also known as Emergency Brake Assist, EBA, is another piece of car braking technology. As the name suggests, is responsible to assist the driver in emergency stop situation. The braking system will work more swiftly when there is sudden braking, if it is equipped with the BA feature. This feature, aimed at making sure that the brakes are applied in case of an emergency, if the driver is unable to respond quickly enough. This happens a lot that in case of sudden braking, the driver is not able to press the brake pedal fully. However, an average driver isn't actually fast enough for a situation like this, where a millisecond of delay can translate to catastrophe. This is where braking assist steps in. With brake assist, the electronics sense the speed and force with which the driver pressed on the brake pedal and apply additional pressure on the pedal for full braking. A travel sensor attached to the brake pedal that allows the brake assist system to detect when the driver attempts an emergency stop, and regardless of the amount of pressure actually applied, it will apply maximum braking force until the car is brought to a stop. Some more recent braking assistance systems can detect a sudden liftoff from the gas pedal, or receive imminent crash warnings from radar or camera-guided crash detection systems and prime the braking system. That way, when the driver slams the brakes, maximum braking force is available immediately. This system works with the three main components: accelerator sensor, brake sensor, and electronic control unit. Let's consider an event of normal braking. During such event, driver lifts off foot from accelerator and presses brake pedal. The same actions are performed even in the case of emergency braking, but with greater intensity. ECU measures this intensity with the help of inputs from accelerator and brake sensors and determines whether driver has encountered an emergency. If it is found that the braking is due to an emergency, then ECU orders the brake booster, a component of brake system that can control pressure of braking, to apply more pressure on brakes so that vehicle could be brought to a stop early. Of course, the system takes care that the pressure applied is always optimum. Undoubtedly, this system is very useful in reducing the stopping distances during emergencies as it applies optimum brake force almost instantly. Also, this system has helped saving many lives by avoiding accidents. Mercedes-Benz is the first manufacturer to offer this system as a standard feature on all its vehicles since year 1998. So what do you think about these braking systems?